Here's a question that sounds simple, but isn't. If you gave an AI everything a scientist knew right before their big discovery, could it guess the discovery itself? Not summarize it, not explain it after the fact. Predict it from scratch using only the clues that existed before it was found. That's a completely different skill than what AI is usually judged on, and a new benchmark just tried to measure it directly. Stick with me, because the answer is more interesting than a simple pass or fail. Let's set the scene. Today's AI models are genuinely impressive at working with science. They can read a dense paper and explain it in plain English. They can compare 5 competing theories side by side. They can spot patterns across thousands of documents faster than any human ever could. But there's a harder question hiding underneath all of that. Reading what's already been discovered is not the same thing as discovering something new. And that gap between understanding science and doing science might be the single biggest wall AI research is facing right now. So a group of researchers built something clever to test it. They called it Reconstruction. Here's how it works, and it's honestly a really elegant setup. Imagine a scientific paper sealed inside a locked box. You can't read the title. You can't see the abstract. You definitely can't search for anything published after it. That would be cheating, obviously. All you get is the trail that led up to it, the exact list of papers the original researchers had already read before they made their breakthrough. That's it. That's your only clue. And your job is to figure out what idea was hiding inside that locked box. Simple to explain, brutally hard to actually do. To make this fair, the researchers didn't just wing it with a handful of examples. They pulled 643 real papers spanning 6 completely different scientific fields: machine learning, astronomy, chemistry, materials science, medicine, and physics. For every single paper, they rewound the clock. Only references published strictly before that paper were allowed to stay. The target paper itself, fully hidden, locked away. And here's the clever part that really tightens the test. They stripped the citations of their identity. No famous author name, no prestigious journal, no hints from reputation, just reference 1, reference 2, reference 3. No shortcuts, no name dropping your way to the answer. Just the raw evidence trail and nothing else. Now, why does this distinction actually matter? Think about it this way. If you ask an AI, what did this famous paper discover? And the AI has already seen that paper somewhere in its training, that's just memory. That's recall. That's not intelligence, that's a lookup. Reconstruction asks something completely different. Could the model have figured out the idea before it existed, using only what was available at the time? That's not memory. That's inference. That's the actual skill scientists use every single day. So they ran the test. 7 of today's most advanced AI models, each one handed the same blind bibliography, each one asked to propose 5 possible hypotheses for what the hidden paper might have discovered. And the grading was strict, really strict. Getting the general topic right wasn't good enough. Using similar terminology wasn't good enough. The core scientific idea had to actually line up with the real hidden answer. So, how'd they do? Honestly, not great. Most models landed somewhere between 3 and 15%. Let that sink in for a second. The single best model in the entire test barely scraped past 13%. Now, before you assume that means AI barely understands science, it doesn't mean that. It means something more specific. Under this exact blind setup, only a small slice of the model's guesses matched the one idea the original researchers actually landed on. And when you really think about it, that kind of makes sense. Here's an analogy that helped me wrap my head around it. Give someone a giant pile of scientific literature, and there might be dozens of plausible directions they could reasonably guess. Understanding the landscape of a field is one thing. Predicting the exact path one specific researcher happened to walk down, that's something else entirely. Because real breakthroughs are often weird. They come from unusual combinations nobody expected. A tiny connection between 2 unrelated fields. A strange reinterpretation of an old experiment. A limitation that quietly points toward a totally different approach. The bibliography shows you the whole neighborhood. It doesn't tell you which house actually matters. And that, right there, is exactly where today's AI still struggles. But then the researchers did something that completely changed the story. Instead of asking one model to solve the mystery alone, they built a team, 4 strong models, each one looking at the exact same references completely independently, each one generating its own 5 hypotheses. So instead of 5 possible guesses on the table, now there were 20. And here's the part that actually made the difference. The models reviewed each other's work. They challenged weak interpretations. They compared competing explanations side by side. They argued. and the candidate ideas went through something like a tournament, round after round, weaker guesses getting eliminated, stronger ones surviving. It's not unlike how peer review works in real science, except instead of humans arguing over months, it happened in one automated pass. So what happened to the score? It jumped all the way up to around 36% on average across all 6 scientific fields. In some domains, it climbed as high as 41%. That's roughly 2.5 times better than the strongest single model working alone. Not bad for a group project, but here's where it gets genuinely interesting, and this is the part I really want you to sit with. You might assume the improvement is simple. More guesses equals more chances of getting lucky. 20 tickets instead of 5. The researchers actually tested that exact idea. They tried randomly picking from those 20 candidates instead of letting the models debate and vote. And random selection wasn't nearly enough to explain the jump. The review process itself, the disagreement, the challenging, the back and forth, was doing real work. Think about what that actually means. One model spots a connection nobody else noticed. Another model questions whether that connection actually holds up. A third one catches a hidden assumption buried in the reasoning. A fourth pushes back on the entire framing. Instead of one model locking in on its very first plausible idea and running with it, the system creates genuine friction between competing explanations, and that starts to feel a lot less like a chatbot answering a question, and a lot more like a research meeting, the kind where good ideas survive because they earned it. Now, there's one more subtle detail worth mentioning, because it keeps this whole thing honest. When the researchers loosened the bar, just asking, was there at least one good match among all the guesses, the advantage of the multi-agent team got a lot smaller, which tells us something important. The big jump isn't because the system suddenly discovers every hidden paper. It's that the collaborative process is better at surfacing and identifying the genuinely useful ideas out of a messy pile of candidates. That's a real distinction. The system isn't magically becoming a lone genius scientist. It's getting better at navigating a space of possibilities. And that brings us to the honest limitation of this whole experiment. Because there is one, and it's a big one. Reconstruction is about recovering an idea that already exists. The hidden paper has already been written. The researchers already know the correct answer sitting behind the curtain. The AI's job is just to reconstruct something that's already there. That is not the same thing as discovering something genuinely new. A model could get incredibly good at reproducing yesterday's breakthroughs and still completely struggle to create something valuable for tomorrow. Because a true AI scientist would need to do so much more than this test measures. It would need to spot an open problem nobody's solved, generate hypotheses that are actually new, not reconstructed, invented, decide which ones are worth pursuing, design real experiments, run them, watch them fail, and then update its thinking based on that failure. That is an enormously bigger challenge than anything this benchmark tests. There are some honest caveats too, worth being upfront about. The benchmark can't fully guarantee a model never saw the hidden paper somewhere during training, it just prevents seeing it at prompt time. And the final grading is done by another AI model, even with safeguards in place. So this isn't some perfect airtight proof, it's a stress test. A really well-designed one, but still just one piece of the puzzle. So here's where I think this actually leaves us. AI is already remarkably good at telling us what humanity has already figured out. The much harder question, the one that actually matters, is whether it can reason from what we currently know to what we should be investigating next. And this benchmark gives us the first real glimpse of that gap. Not a guess, not a vibe, an actual number. And honestly, the biggest takeaway for me isn't the percentage at all. It's how the score jumped, not from a smarter single model, from disagreement, from models challenging each other instead of agreeing too quickly. Which makes me wonder if the future of AI research isn't one giant model that tries to know everything. Maybe it looks more like a lab. Several different models, different strengths, constant pushback, constant rechecking, all working toward one shared goal, finding the idea nobody's found yet. So, can AI think like a scientist yet? Not yet. But for the first time, we can ask that question with actual numbers behind it, instead of just vague impressions. Give it the trail. Hide the destination. See how close it actually gets. Right now, sometimes, not reliably, but noticeably, meaningfully better the moment it stops working alone.